Welcome to yet another exciting educational video brought to you by Upvision Concepts Academy. Today we'll be looking at non-metals and their compounds. And non-metals are metals or elements that lack the properties of metals, basically. They are generally poor conductors, number one, of heat and electricity. They are not malleable or ductile and exists as gases or brute solid at room temperature. So important non-metal in chemistry curriculum includes hydrogen. Let me list them. You have hydrogen, you have oxygen, you have chlorine. What else? You have sulphur, you have nitrogen. This is endless actually, but I'll stop here. But let's explore each element in terms of physical property, chemical property, preparation in the lab, uses, and keynotes. So the first thing I'll look at is hydrogen. In no particular order, I'll just pick some of these non-metals and we'll just look at it together. So hydrogen, physical property of hydrogen. Number one, how do you spell hydrogen again? Hydrogen. Okay, my word. Okay, so physical property number one, it is a colorless, odorless, and tasteless gas. So it's colorless, odorless, and tasteless gas. You know, anything that wants to form water must have this, because water, pure water, is actually this. Okay, it is the lightest element. This is how it is. This is the chemical expression. The lightest element. Molecular mass is 1. So it is the lightest element. The lightest element. Very light. Okay. Number 3, it is soluble in water. Slightly, not really, just slightly. Slightly soluble in water. So these are the physical properties of hydrogen. How is it prepared in the lab? If zinc reacts with hydrochloric acid, hydrogen is liberated. So zinc reacts with hydrochloric acid. Hydrogen is liberated. Zinc chloride is the product. Hydrogen is liberated. Is this in balance? Is it in balance? This is okay. There should be 2 here. Okay, and there's 2 here. Okay, so it's balanced now. So when zinc reacts with hydrogen chloride, zinc chloride is produced. Hydrogen gas is liberated as a byproduct. That's where you collect it over water. It's a process known as downward displacement of air, because it's lesser than air. Okay, so you collect it over water like this. Understand? Hydrogen, this is water. So whatever reaction is going through, you collect it over water. So air will go down, then hydrogen will come up. Okay, so you collect it over water or by downward displacement of air. Downward displacement of air. Downward displacement of air. Why? Because hydrogen is lighter than what? Air. Okay. So chemical properties of water. Chemical properties, sorry, not water, of hydrogen, please. So I've looked at the physical properties and look at how it's produced. Like I said, it's produced with zinc chloride reacting with zinc reacting with hydrogen chloride. So it collects over water. But chemical properties of hydrogen. Chemical properties of hydrogen. Okay. Number 1, what do we have as chemical properties of hydrogen? Number 1, it combusts with oxygen. Bonds with oxygen. When that happens, what do we get? We have hydrogen reacting with oxygen to give water. Okay, so second chemical property is that it reduces metallic oxide. Remember when we say redox reaction, So it's a reducing agent. It reduces metallic oxides. Okay, I'll give us an example. When this is a metallic oxide, copper oxide, and hydrogen gas, so it reduces it brings out water and liberates copper. Okay, so what are the uses of hydrogen? Number one, it is used for manufacture of ammonia, HEBA process. HEBA process, uses of hydrogen. So we can study more or contact us for more lessons. So use of hydrogen, one, it is used for manufacture of ammonia, Okay, so the process is called the HEBA process. So ammonia gas is normally produced from hydrogen. It is used for hydrogenation of oils. Hydrogenation of oils. What again? Is used as rocket fuel. Hydrogen is used as rocket fuel, and is also a reducing agent. I've alluded to it here in chemical properties. So lesson number 4, I would say it's a reducing agent. So in the lab or in industrial processes, you can use it as a reducing agent. So these are the uses of hydrogen. So the next one we'll go into is oxygen. We'll go into oxygen quickly. Okay, so oxygen is written like this. These are non-metals. This oxygen, the chemical representation of oxygen. Physical properties, number 1. Physical properties. Okay. 1, it is colorless, odorless gas. Colorless and odorless gas. Secondly, it is slightly soluble in water, slightly, it's like a brother hydrogen, slightly soluble in water. Then, third point I have here is it supports combustion. It supports combustion. That means this guy can cause fire to happen. Okay, so how is it prepared in the lab? Laboratory preparation, lab preparation. So how do we prepare pure oxygen in the lab? You can use decomposition of hydrogen peroxide. Hydrogen peroxide is like this, H2O2. So when you decompose it, you get water and oxygen gas liberated. So you must do it in presence of this catalyst. This catalyst is a manganese oxide. Okay, so it is collected over water. Like hydrogen is collected over water. So both of them are collected over water. Understand? Because oxygen is less dense than air. So it is downward presence of air. That is how we can collect the oxygen over water. So chemical properties, haven't seen the physical properties. Let's go to the chemical properties of water, of oxygen, please. Chemical properties of oxygen. Chemical properties. Properties number 1. Most importantly, I like this first one. Combines with most elements to form oxide. So it combines with most elements to form oxide. Okay, so you have then it supports combustion, so it can burn. Supports combustion. Okay, so uses of oxygen. It is used as breathing gas. Uses number 1. It is used as breathing gas in the hospital. Okay, so to support patients who have difficulties in taking in air. Okay, hospital. Oh, my word. Okay, it is used for welding and cutting metals. Number 3, combustion engines. Number 4, manufacture of steel. Manufacture of steel. These are the uses of oxygen. Oxygen. Okay, so we'll go to the next one, chlorine. So chlorine is another non-metal that we will study. Properties include, physical properties include that it's a greenish yellow in appearance, gas, and with a pungent smell, very pungent, with a pungent smell. You can't stay where chlorine is produced. Can cause choking. It's poisonous, actually. Poisonous. And it's soluble in water. So it can readily dissolve in water. Soluble in water. Okay. It forms weak hydrochloric and hypochlorous acids. So how do we prepare chlorine in the lab? We prepare chlorine in the lab by reaction of manganese oxide plus chlorine to give us manganese chloride, water, and chlorine. This balance, this is 2 here. This is 2 here. Okay, it's balanced now. Okay, so so it is collected by downward delivery because it's denser than air. You see, oxygen and hydrogen upward delivery, chlorine downward delivery. Okay, so chemical properties include number 1, it combines with hydrogen explosively in sunlight. Number 2 chemical property is that it's a bleaching agent. Number 3 chemical property is that it reacts with water. Okay, reacts with water. So what are the uses of chlorine? Number 1, water purification. You have heard most times where we say you want to purify water, you add chlorine. So it's used for water purification. Number 2, for bleaching fabrics and paper. So number 3 use of chlorine is it's used for making PVC and hydrochloric acids. Then number 4, disinfectant and antiseptics. So we'll move on to the next one, sulfur. So sulfur, physical properties of sulfur is a yellow, solid, non-metallic. In nature, it's brutal, insoluble in water, and burns with blue flame. So allotropes, that's other forms of sulfur. Allotropes include rhombic sulfur. This one is stable at room temperature. Stable at room temperature. Rhombic sulfur. The second one is monoclinic sulfur. Monoclinic sulfur. This one now is stable at higher temperature, not room temperature at all. It's stable at higher temperature. Room temperature is 25 degrees Celsius. So when you are hearing that word, room temperature, that's 25 degrees Celsius. So how is it prepared in the lab? Lab preparation. How is sulfur prepared in the lab? So note how all these non-metals are prepared and how they are collected. Okay, so it is extracted from underground deposits using Frasch process. So this is the process, Frasch process. So it's extracted from underground deposits using Frasch process. Chemical properties, number 1, it burns in air to form sulfur 4 oxide. So sulfur like this burns in air to form sulfur 4 oxides. This is air here. Okay. So second property is that it dissolves in water to form acidic solution. So when sulfur dissolves in water, it forms acidic solution. So what are the uses of sulfur? Number 1, we use it to manufacture sulfuric acid. Uses number 1, manufacture of acids. Sulfuric acid, H2SO4, sulfuric acid, old name. Okay. It is used for vulcanization of rubber. Vulcanization. And thirdly, production of fungicides and insecticides. So pesticides and fungicides. Okay. So fungicide and insecticides. Sorry. Fungicide and insecticide. Let me just put insecticide. I'll call the other one fungicide. Insecticides. Okay. Finally, we look at nitrogen. Nitrogen is a non-metal. Physical property is that it's colorless, odorless, and tasteless gas. You see all these gases that are odorless, colorless, and tasteless. There's a way you can test them in the lab. You know, when we talk about quantitative chemistry, we see all those what you can use in testing for this. Other properties include inert under normal condition. Inert means that it doesn't react at all under normal condition. Under normal condition. So when you put it there with anything, you just stay there. It's not do anything, it's not react. Okay, so it's slightly less dense than air. Slightly less dense than air. Okay. How do you prepare nitrogen in the lab? You pass air over heated copper and through alkaline propagol. Okay, so that's how you prepare nitrogen. Okay, so chemical properties include number one, combines with hydrogen in the Haber process to form ammonia. Okay, so this is the Haber process. Nitrogen plus hydrogen will give ammonia. Okay, so there's a 2 here. All right, so what are the uses? So number one, use manufacture of ammonia. Then secondly, nitrogen can be used to preserve food. Food preservation, nitrogen. Then thirdly, it is the innate atmosphere, because it does not react anyhow for chemical process. So it provides innate atmosphere for chemical process. Then finally, you can use it in filling electric bulbs. So the space inside the electric bulb, nitrogen can be there. So common reaction involving non-metals. For all non-metals, there are common reactions. All of them. Common reactions. Common reactions involving non-metals. So generally, what is common among them? Number one is combustion. So they burn. Non-metals generally form acidic oxides. Then number two, acid-base reactions. Acid and base reactions for non-metals. Many non-metals dissolve oxides in water to form acid. And finally, you have oxidizing and reducing behavior. These are the common reactions and reducing behavior for non-metals. So here we are talking about chlorine is acting as oxidizer, for instance, and hydrogen is acting as a reducer, for instance. All right, so I have some questions, past questions, NECO, WAEC style, JAMB style in the description of this video and in the comment section. If you have not liked our video, please like the video if you are impressed. And if you also are not subscribed, you can subscribe. So I hope this video has been informative for you. I'd like to thank you.